Hello, algebra students. Excuse me. We are going to talk about function notation. So we've talked about how a relation can be a function, and now we're going to talk a little bit about how we write that in algebra and what we do with it. So if you would look, as you know, a function equals each input going to only one output. So when we push the Coke button, we should get a Coke. Similarly, when we are worshiping God, if you think about us and praising and worshiping God, if we are doing that through reading the Bible, through listening to Christian music, to praying and keeping a prayer journal, those all help us to function as good Christians. But when we are maybe in chapel or trying to praise God in church or something else like that, and we're thinking more about our phone and our social status and things like that, our praise and worship is not really functioning as well because we are putting other things before God. So it is important when we're praising and worshiping that we put God first. Put all of our other stuff down and focus on Him, because this doesn't function. All right, with that said, this is an example of function notation. This says f of x equals 2x plus 4. So that x can be replaced by anything. It can be replaced by a number. It can be replaced by a symbol. And when you look at this, this is what we're doing. We're simply substituting this in for wherever our x is in our expression. So it's simply a substitution problem like what we've been doing since chapter 0. So really no different, just looks a little different because of the function notation. So if we look at f of x equals x squared minus 4x, and we substitute a star, then each place that there is an x, we would substitute a star. So it is simply substitution. Don't get confused by the fact that it's called function notation. Big words don't need to confuse us. Okay? So with that said, I'd like you to look at these different notations. Here we have an equation, y equals 2x plus 4. And here we have function notation, f of x equals 2x plus 4. I want you to just jot down some similarities and differences in these two notations. And we will talk about those in class. Okay? Now, do that, then go to the next problem. So if we were going to solve these, and we had the equation y equals 2x plus 4, and we're going to solve for x equals 3, what would we do? I'm hoping you said we would put the 3 in for the x. You are correct. So what does that look like? Well, I put my 3 in where my x is, and then by order of operations, what do I need to do next? Multiply, because there's multiplication. I get 2 times 3 is 6, and 6 plus 4 is 10. Fantastic. All right, now let's look at the other one, function notation. Function notation reads like this, f of x equals 2x plus 4. And I want you to solve this for f of 3. Okay, so all I'm going to do is I'm going to put my 3 where my x is. So this f of 3 is in that same, the 3 goes in the same spot that the x is. Okay, again, same order of operations. I still have to multiply and get 6 plus 4, which equals 10. So you'll notice they're the same. Maybe that helps with that other screen. So again, the way that we read this is f of 3. So whatever's in the parentheses is your of, okay? So our f or our g, in this case down here, f tells me which definition to use. So in number 1, I have to use the f function, which is this one. In number 2, I have to use the g function, which is this one. And so it tells me what I'm going to be substituting into and what it looks like. So f of 3, I'm going to use 2x minus 6. All right, let's look at how to write that. All right, so when I have f of 3, I'd like you to write down the definition. F of x equals 2x minus 6. And then in that next step, do your substitution. Put your 3 in for your x here and your 3 in for your x here. If you do this step right here, this first step, it will be very, very, very helpful in keeping track of where your 3 will be going. Okay? The more work you show on these, just like our order of operation problems, the more work you show on these, the easier this is going to be. Okay? So now this side here is just going to keep coming down, coming down, coming down. And this side here, we're going to calculate a number. So what do we have to do first? Now that we have our substitution, go to PEMDAS, any parentheses? Yeah, but not parentheses because there's nothing in there to solve. So really, they're multiplication. No exponents, but there is this multiplication here, so I need to do that. Okay, 2 times 3 is 6. Bring down your minus 6. And then 6 minus 6, or 6 plus negative 6, is how we really like to say that, would give me 0. Okay? Remember, 0 is an answer. It's a viable number. It's on the number line. Wouldn't be an answer if it wasn't on the number line. So 0 is an answer. Don't get confused when that is the case. All right, now let's talk about number 2. Number 2, we need to use that other definition. Now look here, like where my screen is right now, I don't know what G is. So again, write that definition underneath. Write this definition underneath this problem. Write that down, and now do your G of -1, and everywhere there's an X, you're going to put a -1. Now, be very careful on this when you do this problem. Remember, -1 squared is -1 times -1. It's not if you do this on the calculator, you have to be very careful. Make sure your negative is in the parentheses, okay? And a negative times a negative is a positive. So that's going to be a +1. And then remember, this is a -3. -3 times -1 gives me +3. And then 1 plus 3 is 4. Fantastic. Fantastic. All right, let's do one more. We're not going to do number 4. So number 4, you can cross out. Okay? We are going to do number 3, though. So number 3, I'd like you to look at, and I want you to make sure that you know how to do this. I'm going to give you the first step in that you're using this definition. Now, I'd like you to try this one on your own, and we'll discuss it during class. So make sure that your same and difference of the equation notation and the function notation are noted on your notes. And then also finish this problem. Your notes are not complete unless you finish this problem. We're going to go through it when we get to class so that you can see if you've done it right. God bless.